Hello everyone, my name is Saad Hashmi and I'll be presenting the paper titled Towards Antifragility in Contested Environments using Adversarial Search to Learn, Predict, and Counter Open-Ended Threats. Here's the outline of my presentation. Let's start with antifragility. Antifragility is a characteristic that goes beyond robustness and resilience. To give an example, let's take the human body's immune system, which becomes more resilient and strong when introduced to previously unencountered viruses. In the computer systems world, this is an ongoing challenge to develop systems that exhibit antifragile properties. And this is also the motivation of our work as to how systems that are operating in contested environments where an adversary is inducing shocks and stress, how can those systems become anti-fragile? Now we'll talk in this paper about aware. However, the properties that we propose, the vision, it can be implemented on any middleware framework. Aware is a generic reusable autonomous middleware framework that aims to make target systems anti-fragile using an externalized approach. Existing literature has shown that anti-fragility could be achieved through self-management and self-improvement. Aware relies on four principles to realize self-management. Intentionality, which is achieved through goals that capture the intent of both the domain system and Aware itself. A virtualization is achieved through proxies that represent relevant domain services or components at the Aware level to create a live model of the target system. And finally, transitivity and duality is achieved through the goal-driven self-adaptation that Aware uses to manage the target system. And an Aware agent manages or adapts the target system through managing or adapting the live model as part of managing itself. The existing version of Aware, it has limited support for self-improvement, and therefore we propose three self-start properties that provide self-improvement, namely self-exploration, self-learning, and self-training. In self-exploration, an Aware agent anticipates potential attacks on the system, the effects of those attacks, and the countermeasures the Aware agent should take for those attacks. Now, this is achieved through adversarial research, and using adversarial research is not a novel approach for dealing with adversaries. It has been previously applied for solving games such as chess and Go. However, in chess and Go, the action space of the opponent or the adversary is limited and known, whereas an Aware agent's adversary has an unknown action space. Therefore, we rely on only the effects of the adversary's actions on our system. One thing to keep in mind is that this effect space of the adversary's actions gets large, and therefore the exhaustive search algorithms, for example, the minimax, they become infeasible. So our search algorithm is based on the Monte Carlo tree search, which has a capacity to deal with a higher branching factor than minimax. Now let's look at this scenario where we have an Aware agent that is managing multiple domain services that are collecting audio, video, and spatial data. And this data can then be later sent to an in-theater cloud or an out-of-area cloud for further processing, and classification, and filtering. Now, these requirements are represented through goals that an aware agent aims to satisfy. And the top level goal can be decomposed into sub-goals using the AND or decomposition. And what we have is, in the goal schema, we also have the goal satisfied and goal drop conditions. And from the current state, the algorithm runs multiple rollouts, and each rollout ends when the state has satisfied the top level goal or it has not satisfied the top level goal. So either the drop condition is met or the top level goal is satisfied. And the purpose of running multiple simulations is to figure out what the possible end state might be, and therefore what is the best action to take at the current timestamp. The limitation of self-exploration is that the set of next possible states to explore become very large when either the number of goal attributes they increase or the possible set of values of those goal attributes increase. And given the limited resource budget, an aware agent can only explore a fraction of that large number of possible states. So to overcome this limitation of large branching factor, we have the second self-start property, which is self-learning, where we reduce the number of branches to the probable branches based on the adversary's previous behavior. And self-learning is a more broad concept than online learning or continuous learning, where in here, an agent needs to identify the needs and opportunities for learning, defining its own learning tasks, then finding the necessary resources for learning, and at the end, evaluating its own performance on the learned tasks to determine should the learned model be deployed or not. The limitations of self-learning, however, are that it requires large amount of data for training, which is not always available. And secondly, if a novel or a previously unseen adversary is encountered, an aware agent may not know what's the next likely effect of the adversary. And to overcome these limitations, we have our third self-start property, which is self-training. And in here, we do this training by creating an adversarial agent with the opposite capabilities of an aware agent. So an adversarial agent would be disrupting the services. And then there's this joint training of aware and adversarial agent using adversarial reinforcement learning, where in the training, we alternate between which agent learns and which agent executes their learned model, similar to the concept of policy iteration. And once self-training is completed, the learned model is also then used to guide the MCK search in self-exploration, as in if a previously unseen adversary is encountered. So the idea is that a similar adversary might have been encountered in self-training, and so an aware agent would know what the next likely effect of the adversary action would be. These three self-start properties in our vision paper have been discussed and proposed for a single aware agent and a single adversary. However, that's not always the case. And so in future, we aim to extend these three self-start properties for multiple agents where they are defending against multiple adversaries, and the multiple aware agents would be coordinating and collaborating with each other, and also would be sharing information with each other to differentiate between, let's say, identifying different types of adversaries, such as aggressive adversary, probing adversary, and so on. For more details, please read our paper. Thank you very much.